The last type of confidence interval involving means to be considered here is confidence intervals for the difference between the means of two separate populations. As an example, consider computing a confidence interval for the difference between the means of the two populations illustrated in this plot. These populations are assumed to be separate independent populations that have been exposed to different treatments or different conditions, and where the purpose of computing the confidence interval is to estimate the effect of the treatment. Unlike matched pair data, samples from these populations are independent samples, not measurements from the same individuals before and after treatment. The confidence interval can be computed by collecting samples from each population and using the mean difference CI function with those samples as arguments. This confidence interval is computed using a formula with the same basic structure as the formulas used for other confidence intervals. This formula gives the endpoints of the confidence interval in terms of the difference between the sample means, x1 bar and x2 bar, a critical value t star, and the standard error SE. The difference between the sample means is a point estimate for the difference between the population means. Computation of the critical value and the standard error is complicated by the fact that, unlike the confidence intervals considered earlier, the underlying sampling distribution is not a commonly tabulated distribution, and so the critical value and the standard error are usually computed using one of several approximations. The mean difference CI function uses a common approximation called Welch's approximation. In this approximation, the standard error SE is given in terms of the sample sizes N1 and N2 and the sample standard deviations S1 and S2, and there is a rather complicated formula that gives the effective degrees of freedom DOF in terms of the sample sizes and standard deviations. The critical value T star is computed using the student T distribution with that value for the degrees of freedom. After entering all of those values, evaluating the confidence interval formula gives the same result as the result from the mean difference CI function. It isn't usually necessary to remember these formulas or use them directly since they are already programmed into the computer. Also, other approximations can give slightly different results for the confidence intervals. Most of the approximations get better with increased sample size, and differences between different approximations are usually not big enough to be of much practical significance. A common special case comes up if the two populations are expected to have the same variance, in which case the variances of the two samples can be combined to get a better estimate for the population variance, which leads to different formulas and a different confidence interval. The assumption of equal variances is specified by including the equal variances true option in the mean difference CI function. The structure of the confidence interval formula is the same as before, but different formulas are used for the standard error SE and for degrees of freedom DOF. The critical value T star is computed using the student T distribution, and after those assignments, evaluating the confidence interval formula gives the same result as the result from the mean difference CI function. If the equal variance formulas are used when the two populations do not have the same variance, then these formulas will usually give inaccurate confidence intervals. There are also formulas to handle the less common case of comparing populations with known variances. The known variances can be entered using the known variance option. Like other formulas for confidence intervals, when the population variance is known, the formula for this confidence interval uses a critical value Z star that is computed using the normal distribution. The formula for the standard error is exact, not an approximation. After those assignments, evaluating the confidence interval formula gives the same result as the result from the mean difference CI function.